Module 4, Lesson 31, we're going to look at problems in mathematical terms. We're going to start with example 1. Marcus reads for 30 minutes each night. He wants to determine the total number of minutes he will read over the course of a month. So he wrote the equation T equals 30 times D to represent the total amount of time that he spent reading, where T represents the total number of minutes, and D represents the number of days that he read during the month. We're going to need to determine which variable is independent and which is dependent, and then create a table to show how many minutes he has read in the first 7 days. So first of all, our independent variable, and this is the one that doesn't change. It's just set in stone. The independent variable is the number of days. Because days are days. Which would mean that our dependent variable then is the total minutes that were read. And it is, of course, dependent on the number of days that he reads. That's what makes it a dependent variable. Again, just so we're clear, the number of days simply stands on its own. Nothing changes. The number of days does not change as a result of anything happening in the problem. On the other hand, our dependent variable, which is the total number of minutes that are read, is dependent on how many days he read. So it makes it a dependent variable. Now we'll go into our table and we're going to put our independent variable first, because the independent variable is the number that you're going to do something to then get our dependent variable. So our independent variable, which is number of days, we'll label that as D. Will be on the left, and the total minutes read, which we represent as 30 times D, because he's reading 30 minutes each night, is on the right. And remember, this is our dependent variable because it is dependent on how many days he read. So it changes as a result of the number of days that he read. And then we'll fill out our table. If he reads 1 day, it'll be 30 minutes read. 2 days is 60. 3, of course, is 90. 4 is 120. 5 is 150. 6 is 180. And 7 is 210. In example 2, Kira designs websites. She can create 3 different websites each week. Kira wants to create an equation that will give her the total number of websites she can design, given the number of weeks she works. We need to determine the independent and dependent variables, and then create a table to show the number of websites she can design over 5 weeks, and then finally write an equation to represent the number of websites she can design when given any number of weeks. So first of all, the independent variable would have to be our number of weeks worked. Because that can't really change. Our dependent variable will be the number of websites that she designs, which again is dependent because the number of websites she can design depends on how many weeks she works. And our equation then would be D, the number of websites designed, would be 5 times W, 5 times the number of weeks she works. Next, we'll go to the table. And again, we're going to put our independent variable on the left. This is the number of weeks. And on the right, the number of websites. And the number of websites is 5W. The number of weeks, of course, is W. And then we'll fill in our table. If she works 1 week, she'll have 5 websites. 2 weeks, she'll have 10. 3, she'll have 15. 4, she'll have 20. And 5, she'll have 25. Next, we look at example 3. Priya streams movies through a company that charges her a $5 monthly fee plus $1.50 per movie. So we need to determine the independent and dependent variables, write an equation to model the situation, create a table to show the total cost per month, given that she might stream between 4 and 10 movies in a month. So our independent variable is going to be the number of movies. Our dependent variable will be the total cost per month. Because remember, how much she pays per month depends on how many movies she rents. Now her equation, cost is going to be equal to 150 times the number of movies plus the $5 monthly fee. Now we'll go into the table. And again, our independent variable stays on the left. It is the number of movies, which we're going to represent as M. And then the dependent variable, which is our total cost per month, will be C. And this is slightly different than what we've done in the other examples. And they asked us to create our table based on her streaming between 4 and 10 movies in a month. So we're going to start with 4. If she streams 4 movies, that is 4 times 150, which is 6, plus $5, which is 11. If she streams 5, that's 5 times 150, which is 750, plus $5 is $12.50 per month. If she streams 6 movies, that's $9 for the movies plus $5 per month, and that's $14. If she streams 7, that will be $10.50 for the movies plus 5, which is $15.50. 8 movies will be $12 for the movies plus 5, which is $17. 9 movies will be $13.50 for the movies plus 5, which is $18.50. And if she streams 10, that'll be $15 for the movies plus $5 for the fee, which is $20 for the month. Now our exercises are more practice, 4 more problems to practice the same type of situation. Exercise 1, Sarah is purchasing pencils to share, and each package has 12 pencils. The equation n equals 12 times p, where n is the number of pencils and p is the number of packages, can be used to determine the total number of pencils Sarah purchased. Our dependent and independent variables, remember, are going to be in the table the same way as we did in the past. So we want our independent variable to be on the left. Our independent variable are the packages of pencils. Because the number of pencils is dependent on how many packages we purchase, or she purchases. And so our dependent variable on the right will be the number of pencils. Which is represented by 12p. The number of packages is represented by p. Then we need to fill in the table based on 3 to 7 packages. So if there are 3 packages, 12 times p means there would be 36 pencils. If there are 4 packages, 12 times p would mean there are 48 pencils. 5 packages, 12 times 5 is 60. 6 packages, 12 times 6 is 72. And finally, 7 packages, 12 times 7 is 84. Question 2. Charlotte reads 4 books each week. Let B be the number of books she reads each week, and let W be the number of weeks that she reads. Okay. So, our independent variable would have to be the number of weeks, because that can't really change. And we'll call that W, of course. And that was our independent variable. Our dependent variable, then, is the number of books she reads. And B is the number of books that she reads, which is dependent on the number of weeks. Now B is going to be equal to 4W, 4 times W, because she's reading 4 books each week. Then we need to write, we wrote an equation to model the situation. B equals 4 times W. And we're going to make this table that shows the number of books read in under 6 weeks. So if she reads for 1 week, that's going to be 4 times 1, which is 4 books. 2 weeks will be 8 books. 3 weeks will be 12 books. 4 weeks is 16 books. and 5 weeks will be 20 books. So in exercise 3, we're talking about a miniature golf course that has a special group rate. You can pay $20 plus $3 per person when you have a group of 5 or more friends. So we're going to let F be the number of friends and C be the total cost. We need our independent and dependent variables. So our independent variable would be the number of friends. Which we'll represent as F. And our dependent variable then will be the cost. And we'll represent that as C. C is equal to 3 times the number of friends, it's $3 per person, plus 20, which is that initial cost. Now they want us to make our table to show the cost for 5 to 12 friends, so we'll start with 5. And if we have 5 friends, that's 3 times 5, which is 15, plus 20, which is 35. If we have 6 friends, that's 6 times 3, which is 18, plus 20, which is 38. If we have 7 friends, that is 7 times 3, which is 21, plus 20, which is 41. For 8 friends, 8 times 3 is 24, plus 20 is 44. For 9 friends, 9 times 3 is 27, plus 20 is 47. For 10 friends, 10 times 3 is 30, plus 20 is 50. For 11 friends, 11 times 3 is 33, plus 20 is 53. And for 12 friends, 12 times 3 is 36, plus 20 is 56. And then in our final exercise, Carlos is shopping for school supplies. And he bought a pencil box for $3 and also needs to buy notebooks. Each notebook is $2. So we're going to let the total T equal the total cost of the supplies and N be the number of notebooks. Our independent variable would be the number of notebooks, which we'll represent as N. And the total cost is our dependent variable, T, and it's dependent because it depends on how many notebooks he purchases, and of course he's also buying the pencil box for $3. Then they asked us to show the cost for 1 to 5 notebooks. So if he has 1 notebook, that is 1 times 2, which is 2, plus 3, which is 5. If he has 2 notebooks, 2 times 2 is 4, plus 3 is 7. If he has 3 notebooks, 3 times 2 is 6, plus 3 is 9. For 4 notebooks, 4 times 2 is 8, plus 3 is 11. And for 5 notebooks, 5 times 2 is 10, plus 3 is 13. So his total cost then would be $13 for 5 notebooks.